A massive electrical spark known as lightning can form between clouds, in the air, or on the ground. Air serves as an insulator between the positive and negative charges in the cloud and between the cloud and the ground during the early stages of development. This insulating capacity of the air dissipates when the opposing charges accumulate to the point when lightning, a sudden discharge of electricity, occurs. The atmosphere's charged regions are momentarily balanced by a lightning strike until the opposing charges start to build up again. Intracloud lightning, or lightning between opposing charges in the cloud and the ground, can happen within a thunderstorm's cloud of electrical charge, cloud-to-ground lightning. One of the first observed natural phenomena on Earth is lightning. It can be observed in volcanic eruptions, ferociously hot forest fires, surface nuclear detonations, significant snowfall, powerful hurricanes, and, obviously, thunderstorms. The majority of lightning flashes caused by storms, if not all of them, begin inside the cloud. A channel forms downhill and toward the surface if a lightning flash is about to strike the ground. Buildings, trees, and bushes begin to send up sparks to meet it when it is within around 100 yards of the ground. A significant electric current surges quickly down the channel to the spark source when one of the sparks connects to the downwardly forming channel. In comparison to the surrounding ground, tall things like trees and skyscrapers are more likely to produce one of the connecting sparks, making them more likely to be struck by lightning. Mountains are also useful as targets. This does not necessarily imply that tall things will be hit, though. Even when the tree line is nearby, lightning can still strike the earth in an open area. It takes a long time for lightning to form. Although there is disagreement about the precise mechanisms by which a cloud accumulates electrical charges and how lightning forms, we largely agree on the circumstances that must exist for lightning to occur. Scientists believe that little hail particles called graupel, which range in size from 1/4 of a millimeter to a few millimeters, and which expand by accumulating even smaller supercooled liquid droplets, are initially responsible for the formation of charged zones in thunderstorms. These graupel particles get one charge when they contact and bounce off smaller ice particles, while the smaller ice particle acquires the other charge. The charge on ice particles separates from the charge on graupel particles in updrafts because the smaller ice particles rise more quickly than the graupel particles do. As a result, the charge on ice particles accumulates above the charge on graupel. These lightning facts will, well, shock you. They range from odd lightning strike rashes to bursting trees. Thunder cannot exist without lightning. This is because lightning produces thunder, which is a sound. A charged, extremely hot lightning bolt moves through a resonating tube. You can hear the roar of thunder when the air in the tube rapidly expands and contracts, generating vibrations. People struck by lightning experience an unusual rash. One of the little-known facts of lightning is that persons who are struck by it frequently develop red Lichtenberg figures, which are branching, tree-like patterns made by high-voltage electrical discharges traveling along the skin. An exploding tree is a result of lightning. Imagine a tree branch being struck by 15 million volts of electricity. The most probable outcome? As the heat spreads through the tree, its sap is vaporized and steam is produced, which causes the trunk to blow up. Hundreds of lightning strikes occur every hour over a lake in South America. More than 300 evenings a year, flashes of light fill the sky above the Catatumbo River and Lake Maracaibo in northwest Venezuela, frequently many times a second. The region set a record for the most lightning strikes per square kilometer last year thanks to an unusual weather pattern where warm trade winds from the Caribbean Sea combine with cool air descending from the Andes. One of those flash facts that barely everyone is aware of is this. Real petrified lightning exists. The intense heat produced when lightning strikes sand or rock can cause minerals below the surface to vaporize and form a tube known as a fulgurite. These lightning fossils, albeit rather uncommon, have been located all across the world. Many people are terrified of being struck by lightning. Astrophobia, which is the dread of stars, is the third most prevalent phobia in America, behind acrophobia, fear of heights, and zoophobia, despite the minuscule chance of getting hit by lightning in your lifetime of 1 in 12,000 people, fear of animals. But take caution, according to scientists, by the year 2100, the likelihood might rise to around 1 in 8,000. Having a better sense of security during a storm may result from knowing these crucial lightning facts. Hot lightning. You already know that lightning may cause a tree to erupt and that it can give those it strikes a rash. The heat of the lightning itself is the cause of both of these effects. The air immediately surrounding a bolt of lightning can become 5 times hotter than the sun. Lightning moves through the clouds. Even though 100 lightning strikes from clouds to the ground strike the planet's surface every second, some of the most frequent types of lightning miss Earth. A cloud flash is the name given to this form of lightning. While knowing the facts about lightning is useful in a storm, you need also be aware of the many kinds of clouds that can be used to forecast the weather. Without rain, lightning can strike. The rainstorms you're used to associating with forest fires don't always accompany the lightning strikes that frequently start them. In the United States, the states in the West are where dry lightning, as it is known, is most likely to occur. You witness flashing lightning. When you observe a lightning strike, it's not literally lightning from the clouds to the ground. One of the lightning facts that is frequently misunderstood is that lightning may be seen striking the earth. In actuality, the reverse of what you perceive during a thunderstorm. Lightning that strikes the ground has a negative electric charge, whereas most things on Earth have a positive charge. According to the adage that opposites attract, a visible flash will occur when lightning strikes an object on the ground. Yes, it zooms at a rate of around 1/1,000,000th of a second. As quickly as lightning. While lightning strikes actually move at a relatively slow 270,000 miles per hour, the flashes we see as a result of a lightning strike move at the speed of light, 670 million miles per hour. Accordingly, it would take roughly 1.5 seconds to go from London to Bristol or around 55 minutes to reach the moon. Helicopters trigger lightning. It was recently discovered by the Met Office that a single lightning strike can be brought on by a helicopter. The helicopter picks up a negative charge while it is in flight. Therefore, if it flies near an area that is positively charged, such as hail or a positively charged region of a cumulonimbus cloud, it may cause a lightning strike. Yet it can promote plant growth. While nitrogen is present in the air all around us, plants rely on a process known as nitrogen fixation in order to be able to absorb it, a process essential for their growth. Even though bacteria and algae handle a large portion of this process, the intense heat of a lightning strike allows nitrogen to link with oxygen to form nitrogen oxides, which when combined with air moisture fall as rain and provide plants with nitrate-rich water. Lightning count. Simply count the seconds that pass between a lightning strike and the subsequent thunderclap to determine how far away a thunderstorm is. You may calculate how far you are from the storm by multiplying this number by 5 or divide by 3 for the distance in kilometers. You may not be aware of this, but up until the late 18th century, many church bells were inscribed with the phrase, "I pursue lightning," since it was thought that ringing them would deter lightning. Bell ringers would rush to the bell tower to ring the bells during a thunderstorm. The worst place to be, though, was a tall tower with a metal bell. In France, 103 bell ringers were killed by lightning strikes between 1753 and 1786, which led to the prohibition on the practice. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.